Hi, assuming that you completed the previous lecture, you now have a good understanding of what the general purpose input-output pins are on the Arduino. These are the pins that you find on the long header. Most of the long header pins are general purpose input-output and the analog part of the short header. These pins provide a good way to communicate with things such as buttons or LEDs, and specifically to be able to read the status of a button, for example, or a potentiometer, or to change the status of an LED, turn it on. But what if you need to communicate with something like this? This is a graphics screen or LED, organic LED screen, or with something like this, which is a 3-axis accelerometer and gyroscope. It helps you detect position and movement of a gadget, or even something like this, a GPS module. So for things like these, simple general purpose input-output pins are not sufficient. You could do the job, it's just a not very efficient way of communicating with sophisticated sensors or external devices. So to make it easy to connect such devices to your Arduino and have efficient, fast communication, we need communications protocols. Your Arduino comes with built-in communications protocols, and this is what this lecture is about. So in the remainder of this lecture, I'll talk about the communications options that come with the Arduino Uno. Let's begin. Looking at the Arduino Uno headers, we do have some clues that there's something more going on with the header functionality other than simply power and the general purpose input-output pins. Especially if you look at the long header, you'll see that there are some pins with special markings. For example, pins number 0 and 1 are marked as RX and TX, as well as 0 and 1. And then at the other end of the large header, the long header, you've got SCL and SDA. Now, what do these markings mean? What could these two pins here and another 2 pins here do? On the other side, we don't really have any other clues other than the functionality of the analog pins as analog pins. So we know that there's something going on here. Well, these 4 pins can be used for communications, and they implement 2 of the available 3 types of serial communication protocols that the Arduino Uno with its Atmega 328P microcontroller make available to us. Let's have a look at the product page of the Arduino Uno on the Arduino website. So looking at the product page, I'm just going to skip all of the bits and pieces at the top part of the page and scroll down, because what I'm looking for in this lecture specifically is communications. So there you go. So there's communications. So having a quick read through the communications paragraph, we learn that the Atmega 328 provides UART TTL 5 volts, which is a serial communication protocol, which is attached to digital pins 0 and 1. So this is a functionality implemented on these 2 pins. These 2 pins implement one of the 3 serial communication protocols, the UART TTL, which is a very classic, very old communication protocol that allows you to transmit data and receive data at the same time. So it's a full duplex type of protocol. The same paragraph on the product page of the Arduino Uno also tells us that these 2 pins are connected or tied together with the serial port that is managed by the Atmega 16U2 microcontroller, this chip right here. So that means that when your computer is connected to your Arduino Uno via USB, it's actually these 2 ports that allow the USB controller to communicate with the Atmega 320P on your Arduino Uno. But when your computer is not communicating with your Arduino Uno via USB, these two pins are available for other devices to use in order to communicate with your Arduino. So for example, have a look at this GPS module. It's got a bunch of pins here, but two of them, these two, are the RX and TX, which means that this device here can communicate with your Arduino Uno. I'll just place them like this for now. Can communicate with your Arduino Uno via the serial interface. So, of course, it's a single serial interface, which means that either your computer or the GPS module will be able to communicate with the Arduino at one given time. You can't have these two different devices, external devices, to communicate with your Arduino at the same time. Other Arduinos, such as the Arduino Mega, for example, have got multiple UART interfaces, multiple serial interfaces. So it's possible then to connect your GPS module to a second full-speed hardware serial interface, and that would allow for multiple such serial devices to communicate with your Arduino at the same time. But I'll just say one more thing about the serial interface, because it is sometimes necessary to have multiple serial devices communicating with your Arduino at the same time. What we can also do is to implement the same functionality using any other digital pin pairs, but emulating the hardware serial functionality that comes with the Arduino. So we use software to simulate the hardware, and that gives us access to additional UART channels, additional serial interfaces. Another common use of the serial interface on the Arduino, other than connecting it to your computer or to devices like this GPS module, is to connect multiple Arduinos together and have them communicating via the serial interface. Just a very simple way to do so.